Let's get started. Thank you for joining me this afternoon to hear about the lessons that we learned while we were developing Spring Boot Gradle support. My name's Andy Wilkinson. I work for Pivotal. I'm a member of the Spring team, so Pivotal are the primary sponsors of the Spring open source projects, one of which is Spring Boot. I'm a member of the core Spring Boot team. So before I launch into this, how many of you have already heard of Spring Boot? Pretty much everyone. And how many of you have used Spring Boot? Pretty much all of you. Okay. For the very few of you who didn't put your hands up, so Spring Boot basically takes an opinionated view of the Spring framework and the other Spring projects and tries to provide a convention over configuration based approach. So you can just drop something on the class path and Spring Boot will kind of bootstrap things for you with some sensible defaults, rather than you having to go through the kind of the slightly tedious work of creating configuration, which can often be kind of, it's just boilerplate really. So Spring Framework was always about, well, let's try and remove boilerplate from your application's logic. Let's just let you focus on the business logic. Spring Boot in some ways is trying to do the same things for your application's configuration. So if it's kind of standard configuration, we don't want you to have to write that. We'll try to auto-configure things for you, but also back off and get out of the way if you have an opinion that's different from ours or you want to customize things a little bit. So Spring Boot and Gradle, why do we have Gradle-specific support for Spring Boot? What is it about Spring Boot that means that it makes sense to integrate with a build system? Well, as those of you who are Spring Boot users know, in addition to be able to deploy a Spring Boot application as a standard WAR file to a Tomcat or Jetty or a Java EE application server, you can also build a fat jar, an executable jar as we call them, which is your whole Spring Boot application contained in a single jar file, and you can run it with Java-jar. In a similar way to what you can do if you use, for example, Maven Shade plugin or Gradle's Shadow plugin. So Spring Boot provides Gradle and Maven plugins for building these fat executable jar files, or indeed an executable WAR file that you can both run with Java-jar or deploy to a servlet container. Give you a quick what that looks like in Spring Boot 2.0. So as when you're building any Spring Boot application, a common place to start is the Spring initializer and start.spring.io. Also integrated with, almost certainly integrated with your ID of choice, as long as your ID of choice is Eclipse, IntelliJ, or NetBeans. They all have plugins so that you can create a new project straight from the ID. I'm going to use the website here though. So you can create a Gradle project or, if you're feeling masochistic, a Maven project. Pick which language you like, Java, Groovy or Kotlin, a version of Spring Boot, and then you can add dependencies. So we just say, right, I'm going to build a web app, add the web dependency, and generate the project for us. And that just downloads a zip file with kind of a skeleton in it to help you get started. So if I unzip that, you'll see here that it's created a bunch of bits and pieces for me, including a build.gradle file and some basic source for the application. So I can just run that. So the first thing I can do is I can just run that up using the boot run task. So this is the same, if you're familiar with this from Spring Boot 1, the boot run task is still there, exactly the same as it was in 1.5, still there in 2.0, so that lets us run our application. So we now have a very basic run web application running. Something that's changed in 2.0, so those of you who are familiar with Spring Boot 1, presumably are familiar with the boot repackage task, which is the thing that lets you produce the executable jar file. That's been replaced in 2.0 for reasons that we'll learn about shortly with with another task called boot jar, which is like boot's take on Gradle's standard jar task. And that builds us the jar file with all of the application's dependencies embedded inside it. So you can see here, here's the various things. So we've got Tomcat in here, for example, so the container that's embedded inside the jar file. Various other things that we depend on, Jackson kind of things that we think are probably standard things that you'd like to use in a web application. And then also some classes here in the root of the jar file, and these are the things that make it executable. These are the classes that first run, so the jar's manifest points to the main class for the launcher, and then it's the launcher that knows how to create a class loader that points to everything that's packaged inside the jar file, all of the jars inside boot-in flib. For those of you who are familiar with Maven Shade plugin and Gradle Shadow plugin, the big difference that you'll see here, so Shade and Shadow, they put everything in the jar file, all unpacked, so all of the class files are all inside the jar file. We take a slightly different approach with Boot's plugin, and as you can see here, we've actually nested the jar files inside the jar, so we have a jar of jars. The reason that we do that is it avoids the problems that you get with Shade and Shadow, where you have to worry about merging resource files together. If you have multiple jars with the same resource files inside them, they have to be combined intelligently somehow. Whereas if we can keep them inside the actual jars, then we don't have to worry about that merging of different resources inside the different jars. The nested jars does bring with it some complications as well, so there are trade-offs. You're not necessarily saying that what we're doing is objectively definitely a better way to do it. And if you like, you can build a Spring Boot application using the Shadow plugin. You don't have to use Spring Boot's fat jar support to use Spring Boot if you don't want to. And then I can just run the application, just Java-jar on the command line, and it fires up the exact same app as I did earlier with the boot run task, but now running from the jar archive that you normally deploy in production, rather than running it via boot run, which is something that you would be more likely to do at development time. So that's kind of a very brief, quick look at where Spring Boot's plugin is in 2.0. So there's the boot run task is still there, and we have the boot jar task and also a boot war task for building an executable war file as well. And now I'd like to kind of dig into kind of the meat of this talk and just talk a bit about the lessons that we learned. We wrote Spring Boot's 1 plugin. We started working on that, I think probably in 2013, maybe even 2012. And the original version of Gradle we were targeting was 1.something, 1.10 maybe. Obviously things have moved a long way since then. We're talking maybe 3-4 years. We're up to Gradle 4 now, So we learned a lot along the way. We made a lot of mistakes. We were new to Gradle. So hopefully now I can talk to you about some of those, and you can hopefully avoid making some of the mistakes that we did. So the first thing that we learned was that you need to be a little bit wary of Gradle's internal APIs. And I say I'm doing this one first because this is probably the only negative thing I'm going to say about Gradle, and I wanted to get it out of the way first. So to understand Gradle's internal APIs, we need a little bit of help from Donald Rumsfeld and his known unknowns and unknown unknowns and known knowns, because with Gradle, the internal APIs, well, you have internal internals, but you also have external internals, and then you also have internal externals. And this is something that really tripped us up a little bit, because we weren't quite clear when we were getting started what bits of Gradle we should be using and what bits we shouldn't. So the internal internals, these are the obvious ones to steer clear of. So anything that's in an org.gradle.something.internal package, you want to leave well alone. So you need to use these with extreme caution. If you're thinking about it, you need to ask yourself, is there not a better way to do this? Because quite reasonably, the Gradle team think that these are internals, and they can change them. In a maintenance release, in a minor release, these may change, and it may break your plugin. Unfortunately, sometimes you'll have to use them. And you may be, well, why? What would mean, why would you have to use them? And that's where the external internals come in. So this is something that is internal, but has actually leaked out into Gradle's externals. So you can see here, abstract copy task. So this is a superclass of Gradle's jar task, and Spring Boot's jar task is a subclass of Gradle's jar task. So that boot jar task that I showed you earlier has abstract copy task in its type hierarchy. And you can see here that we've got abstract task is in an internal package, and also convention task is in an internal package as well. So by subclassing something that is part of Gradle's public API, we actually now depend on Gradle's internals. Which, when I first kind of realized this, and I was convinced that subclassing jar was absolutely the right thing to do, but now I had this dependency on Gradle internals, it made me quite uncomfortable. But as long as you tread carefully, I think you'll be fine. I think when I first saw this, I kind of overreacted a bit. Once I calmed down, Eric gave me a virtual hug and said, it'll be all right, don't worry. The Gradle team have been really helpful with problems that we've had. There's a thread here on discuss.gradle.org that I linked to where I kind of asked the question and we're given quite a lot of reassurance that yes, what we're doing was the right thing, and yes, we know this isn't ideal, and no, we won't break you because we're aware that this stuff has leaked out. So whilst is in an internal package, the Gradle team kind of realized, well, actually, it has become an external now. If you are in any doubt, though, post on discuss.gradle.org. In my experience, the Gradle team and the Gradle community are hugely helpful and will help to guide you and get this stuff right. And there's also an issue here that I've linked to 1156 in the Gradle repo where they're talking about fixing this problem. And they have kind of a plan in place for getting some of this sorted out so that the internals really are all internals and the externals really are all externals. The last one to mention, the internal externals, I think this now is a solved problem. I was bitten at one point, so Spring Boot's plugin depends on another plugin that we've written which provides some Maven-like dependency management support for Gradle, so it lets you use a Maven bomb. How many of you are familiar with the concept of a bomb in Maven? So for those of you who aren't, a Maven bomb is, as you'd expect with Maven, a raft of XML that describes a bunch of dependencies, so it's artifact coordinates, group ID and artifact ID, and a version. And you can basically use it in a Maven-based project to say, if you depend on this library, this is the version that you want to use. So for example, Spring Framework provides a bomb which lists all of Spring Framework's modules in it. So group ID, artifact ID, version coordinates. Doesn't mean that if you use the bomb, all of a sudden you depend on all of Spring Framework, but if you depend on a few of Spring Framework's modules, the use of the bomb guarantees that you get the same version. So you get Spring Core 439 and Spring Web 439 and Spring Web MVC 439. You don't get some horrible mix of versions. Spring Boot has its own bomb and provides dependency management both for Spring Boot's own modules and Spring Frameworks and a bunch of third-party stuff that we know all work together and Spring Boot worked happily with. So we implemented a dependency management plugin for Gradle that you could consume a Maven bomb and get that support for managing the versions in your project. And because it talks Maven, when we were writing it, I thought, oh, look, Gradle brings in a bunch of Maven types. That's really useful. I'll use that too. They're not in an all Gradle internal package. I'll use it. But then they got removed in a minor release of Gradle, and I learned that, well, actually, we consider them to be an internal. And all of that has improved now, I believe, in 3.x. So all of those external kind of third-party things that Gradle itself uses, so some Maven types, I think there's some Ant types and things in there, they're all now in a all Gradle internal impl-dep package. So there's now alarm bell should be ringing because it's inside internal. So hopefully you won't be bitten by the problem where there is something that looked like it was external, but is actually internal. All right, so the second thing that we learned was to use a statically typed language. So why would you want to do that? When we first started writing the Gradle plugins, we thought Gradle equals Groovy in our minds. You write the build.gradle script in Groovy. Let's write our plugin in Groovy. And that worked well to begin with. But as I said earlier, we targeted Gradle 1.x to begin with. But because of the nature of the beast and the way our plugin has to work. In a particular minor release of Spring Boot, we can't suddenly say, oh, sorry, you've upgraded from Spring Boot 1.2 to 1.3. We don't support Gradle 1 anymore, because our users would scream at us. You may be in a better situation where you have more control over what version of Gradle's in use in your organization. But if you don't, and there are people using a wide array of versions of Gradle, then that also means that they may be using varying versions of Groovy. So Gradle 1.x was Groovy 1.8, Gradle 2 upgraded to 2.3, and then in Gradle 2.8 they upgraded to 2.4. So that meant that our Gradle plugin that was targeting 1.x, we were building and compiling that with Groovy 1.8, and then users who were on Gradle 2.8 were then trying to run that Groovy 1.8 code on Groovy 2.4, which is a big ask of Groovy to expect code that's been compiled with one major version of Groovy to then also run with a different major version of Groovy. And it caused us some binary compatibility problems. So the solution to that is to use a statically typed language. So if you use Java or Kotlin, if you choose, then you're not kind of at the mercy of differences in the Groovy runtime that may cause problems with bytecode compiled with one version of Groovy running against a different major version of Groovy. If you are using Java and you can require Java 8, so if everyone in your organization is building against Java 8, you don't have anything on Java 7 or Java 6, then I think that's a really good match for building a Gradle plugin. Java 8's lambdas are a really welcome addition to your toolkit if you're writing a Gradle plugin. Gradle, the APIs rely a lot, kind of the Groovy heritage shows through with a lot of closures in there, and then they're also being accompanied also with an action. So Gradle's action, a single abstract method kind of interface, you can drop in a lambda instead. So if you're able to use Java 8 for your plugin code, it makes it a lot more concise in places where you would have had an anonymous inner class if you were using Java 7 or Java 6. Another lesson we've learned is that TestKit is awesome. How many of you are using TestKit to test your Gradle plugins? Maybe half or so, maybe a third. So for those who aren't familiar, TestKit basically is a functional testing framework, if you like, for your plugins. So it will let you basically pass in a Gradle script and say, run these tasks, and then you can kind of introspect what happens. You can get hold of all the tasks that run and see if they succeeded or if they failed. You can look at the outputs that those tasks have written out onto disk or whatever. The docs on TestKit and Gradle's user guide are an excellent resource for kind of getting up to speed with TestKit. Probably my favorite feature of TestKit is how easy it makes to test your plugin against multiple versions of Gradle. If you don't have the luxury of dictating what version of Gradle everyone uses, you can basically say to TestKit when it's creating a Gradle build environment for you, you can say, and do that with this version of Gradle. And it will does similar to how the wrapper does, it will download that version of Gradle for you and fire it up and then run your build in that version. And it takes care of all of that for you. So it makes it very easy in your test suite to test against lots of different versions if you want to get some reassurances that you have that compatibility. On the subject of testing, when I was talking before about a statically typed language for writing your plugin, I would thoroughly recommend that for the plugin's main code. For the plugin's test code, do whatever you like. If you're a Groovy and Spock kind of a person, then go for it. If you're a JUnit kind of and Java person, then go for it, because the binary compatibility problems that can happen at runtime don't really matter in your tests. That's not a problem that can occur in my experience. One thing about using JUnit, I'll just show you actually. So Spring Boot's plugin, we write Spring Boot is 100% Java. All of the tests are Java and JUnit, and all of Spring Boot's main code is Java. We just have a look now. So one of the beauties of using Spock with TestKit. So as I said, TestKit lets you take a Gradle build script and kind of say, right, run this script. Here's the build script, run these tasks for me, and then you can kind of assert that the right things have happened. one of the beauties of using Groovy and Spock is Groovy's support for multi-line strings. So you can kind of have your Gradle, your build.gradle script that you want to use for the test can kind of just be embedded in with the test. If you're using JUnit because you're a pure Java shop, then you don't have the benefit of being able to put multi-line strings inside your test code. So I just thought it might be interesting very quickly to show you something that we've done to try and make this a little bit less painful. So we have a JUnit rule that we've written, and I'll link to this source code at the end. This is all in GitHub's repository, so you can take a look at that. But I just wanted to show you, so this is the logic here that's basically creating, so it's the Gradle runner. This is the thing that's provided by TestKit. This is kind of your entry point into TestKit. So you can say to Gradle runner, I want to create a project directory, and then here's running with a different version of Gradle is basically as simple as, well, in fact, it's not even the if statement. It's as simple as that. So you can just say to the runner, run this with a particular version of Gradle. If you don't pass in a version, then it just uses the version of Gradle that you're using for this particular build. So if you're building your app with, building your plugin with Gradle 3.5, by default, TestKit will run your tests against Gradle 3.5. So we have this JUnit runner, and then we have a convention that for any particular test class, the script that it will use is basically the name of the test class with .gradle on the end. So here's the script that's used for boot jar integration tests. So these are some integration tests for the boot jar task. And because that is named the same as the test class, then that is automatically the thing that we use. So it's kind of a way of avoiding or lessening the pain of not having multi-line strings available to us. And we've also, by convention, if you want to have a test, rather than test class specific build.gradle script, a test method specific build.gradle script. This gets a little bit unwieldy, but it does work reasonably nicely. So here we've named, so it's, we've named dash and then the name of the test method to say we want to use this test script for this particular test method. And that can be a really nice way to get your test running if you're with JUnit, and also run them against all sorts of different versions of Gradle. We have a compatibility suite here, which just plugs into JUnit's test suite support. And so here we're saying, run against the default version of Gradle, which is the version we're building the plugin with. 3.4.1, 3.5, and 4.0 RC1 at this point. Need to update that to build against 4.0 final as well. And then the use of that custom test suite means that any test that we write and we stick that annotation on will automatically get run against all those different versions of Gradle. So you can see, so this is an abstract class that just, so there you go. So it's run with that particular suite. And when we run them, you'll see there that it's running against the default version of Gradle, 3.4.1, 3.5, and 4.0, just by sticking that annotation on there. Any test that you add to that class will then automatically get run against all those different versions of Gradle. All right. I think this is the biggest lesson that we learned, and this is the biggest thing that we made an absolute mess of when we first started. Our tasks were far too clever, far too clever. Instead, your task should just do what it's told. So your task can encapsulate logic that is incredibly complicated, but it shouldn't be trying to figure out what its inputs are. It's like you could think of your task as kind of a pipeline. You shove a bunch of stuff into it. The task does anything with all the stuff you've shoved into it that can be as complex as you like, and it produces some output. But if your task is looking out into the project to figure out what its input should be, you're very quickly going to tie yourself in knots. So whilst every task has access to the project, I would avoid using it as much as possible. If you'll find yourself looking at the project and looking at something to figure out something that should be passed into your task, then you have almost certainly got something wrong. And instead, you should be looking to configure your task externally. So That could either be by a plugin, so you could apply a plugin that then creates a default version of your task that's there available automatically for the user. So for example, when you apply Gradle's Java plugin, you get a bunch of tasks created for you automatically with sensible defaults. So you'll get like the compile Java task, you'll get a jar task by default. And they all have sensible defaults, but the tasks themselves, the compile Java task and the jar task, they don't really know about those defaults. They're all things that are passed into the task when the Java plugin creates it. Or alternatively, the user could configure the task. So maybe you don't have a plugin that applies the task, and instead you just have a bunch of setter methods that lets the users set everything up on the task and tell it what to do. For some things, though, you can still provide sensible defaults. So for example, something that's not necessarily an input that's based on other aspects of the project and things that are configured. For example, the zip and jar tasks in Gradle, you can have zip64 support, so you can create huge zip files with hundreds of thousands of files in them. There's a default for that zip64 setting. I think it's switched off by default. You can still have that because that default is just something that's solely isolated to the task. It's not something that it's looked out into the project to figure out. It's just default behavior for the task. Going beyond that, you can also have defaults that are to do with other aspects of the project. But rather than the task defining those, you want your plugin to set those up for you on the task. If you're on Gradle 3 or earlier, then this is one area where you have to get your hands dirty with kind of internal, external API. So the convention mapping stuff that's provided by convention task that we saw in the type hierarchy earlier on, that lets you set up by convention the default value for this particular property on the task should be whatever, and that can be set by the plugin. But as soon as the user sets something on that task, sets that property on the task, that convention backs off and it lets the user kind of express their opinion. In Gradle 4, property states has replaced this, so there's now a proper, genuine public API to let you set up conventions on your task. So a default setting, so a plugin can create an instance of a task and make it available in a project by default, and then you can also use property states to say, if the user doesn't express an opinion about this particular property of the task, this is what its value should be. So benefits of doing this. If you get your task right, the most obvious benefit is that you can then unit test it. If you find that you're having trouble unit testing your task because you're having to scaffold all sorts of things hanging off the project, then that would suggest that your task is looking out too much to the project and is messing around with the project to try and figure out what to do. If you get your task right, then it should be possible to unit test it rather than having to integration test it. Another benefit of getting it right is that it will make your task reusable. So if your task is trying to be too clever and looks out into the project to try and configure itself, then that probably means that it will be very hard for the user to configure it and make it behave as they would like, because you probably haven't provided enough configuration options on it. So if instead you let all of the configuration settings get passed into the task, then it will mean that you can reuse it and a user can create a custom instance of your task and set things up as they need. And that kind of brings me on to getting the inputs and outputs right of your task. So these are the settings, the things that you let a user set on a task, and the outputs that the task will produce. So the inputs and the outputs are kind of where a lot of Gradle's magic and benefits come from. And these are the things, so Maven has this really rigorous life cycle where you have to go through all the different phases of the life cycle. Whereas Gradle will just work things out. If you want to run a particular task, it will just work out based on the task's inputs what other tasks need to run before that particular task runs. Whereas in Maven, if you want to run something that's in a particular life cycle phase, then every other phase that precedes that phase in the life cycle is going to have to run, whether or not it's actually going to do anything. So if you get your inputs and outputs right, that's what lets Gradle kind of set up this implicit dependency graph between the tasks. If you make a mess of the inputs and outputs, as we did in Spring Boot to begin with, you'll soon find users complaining, say, I ran this task and this thing ran, why did it run? or I ran this task and this thing that should have run before it didn't run. Why did that happen? And if you see either of those things happening, tasks running when they shouldn't or not running when they should, then that suggests that there's kind of some inputs and outputs haven't been set up properly. Another thing that you'll get if you get your inputs and outputs right is that the up-to-date check stuff will all work. So Gradle's ability to avoid running a task. If you get your inputs and outputs right, if it knows, well, none of these inputs have changed, then the output is still there and it hasn't changed since I last run, that task's up to date, there's no need to run it. And as we've been hearing about today, that becomes even more important with the build cache, because it'll let the cache stuff work as well. So you basically need to set up properties on your task for all of the inputs and a property for the output and annotate them appropriately. So Gradle provides the input annotation and various others, input file, input files, but things that basically let Gradle know this is an input to the task and it should be used for things like up-to-date checks, things like for creating the dependency graph between the tasks, and also the outputs. So these are the things to look at as well that are going to be produced by the task and to check if they're up to date. One thing that we got wrong in the boot repackage task, so we came from a Maven background largely, and Maven's kind of very rigid and makes it very hard for you to have a Maven project that produces more than one artifact. It's possible, but it's really difficult. So in Maven, when you want to build a fat Spring Boot jar, we take the original jar and then we repackage it. We rewrite it and shove all the extra jar files in it. And we thought, it's good enough for Maven, it's good enough for Gradle, let's do that. But that completely broke the up-to-date check, because the jar task would run, produce the jar file, and then we'd repackage it and add all of the nested jars into it. And then the next time the jar task ran, it went, oh, someone's changed my output, I need to run again. And then the repackaged task would go, someone's changed my output, I need to run again. So you'd never get any build avoidance for the jar and the repackaging process, because they were fighting with each other and overwriting each other's output. You could avoid it by declaring a classifier so that it wrote it to a separate location, but the default behavior was that we'd then broken the up-to-date check stuff. So it's important to kind of, if you have a Maven mindset or perhaps even an Ant mindset, to kind of leave that behind and kind of get into the Gradle way of doing things and not bring the kind of the baggage and restrictions from Maven or Ant to Gradle when you're starting to think about writing your own tasks. And getting the ins and outs right, I've said here stupid tasks. So by stupid, I mean ones that aren't reaching out into the project. If you get it right and you just basically make everything be properties that you set on the task, it makes it a lot easier to then just annotate those setters and the getters, or annotate the fields to tell Gradle what the inputs and outputs are. It becomes easy rather than becoming something that's difficult to figure out what the inputs and outputs should be. Last thing, pick the right input. So, for example, in Spring Boot, we want to put inside the jar files, we want to put inside all of the jars that you depend upon and your source code. So you could think, well, that's probably the runtime configuration. That's got all of my runtime dependencies. So let's declare that as an input. And then I probably want the classes from the main source set. So let's have that as an input as well. And that would work, but it's not quite as elegant as just using the main source set's runtime class path, because that contains both your own compiled classes and all of your dependencies. So sometimes there's more than one way to do things and more than one input that you could choose. And it's worth just thinking a little bit about, is this the right input? And I don't really have any great advice for, I don't think there's a silver bullet for you figuring out exactly, yes, this is the right input, but it is worth something thinking about, is this the best way for me to express this is what the input to a particular task should be. Lesson number 6, react to other plugins. So we did something to begin with where the Spring Boot plugin would apply other plugins for you. So if you applied the Spring Boot plugin, you'd automatically get the dependency management plugin that I talked about earlier. We thought, well, dependency management's great. Who wouldn't want a consistent set of versions? Let's just apply that plugin. Spring Boot plugin also always applied the Java plugin, because everyone's writing Spring Boot apps is going to be writing them in Java or some other plugin which builds on top of the Java plugin. And people started complaining, saying, well, I don't want to use your dependency management. I've got my own in-house approach to doing that. We have a Gradle resolution strategy that we use for this kind of thing that we share everywhere, or we want to use a different plugin to keep all our versions in step. Can you let me do that, please? And it was very difficult because we said, well, no, we've applied that plugin for you, and we can't undo that. So what we quickly realized is what we should have done is, rather than being very opinionated and say, we're going to apply this particular plugin and we're going to configure it in a particular way, instead, we would react to that plugin being applied. And then so if that plugin's applied, we'd then notice that it had been applied, and we'd configure it in a particular way and provide some sensible defaults. So then if someone didn't want to use that particular plugin, they just don't apply it and they don't get it. So it does mean now for someone moving from Spring Boot 1.5 to Spring Boot 2 who does want the dependency management support, they do have to add an extra line to their build script to apply that plugin. But the benefits that brings in terms of flexibility and control and letting people not use dependency management if they want, or also, I think, arguably makes the build clearer because it makes it obvious that you're using the dependency management plugin rather than it just being kind of applied in secret, I think outweighs the slight increase in the build script file. So here's just an example of the code. It's dead simple. So you project get plugins, and then you say plugins with a particular type. So this could be some, whatever plugin, the Java plugin, some other plugin. And then this lambda here, it's an example of where lambdas work really nicely. If you're on Java 7, you'd have like an anonymous inner class that implemented the action interface here. And then you just stick some code in there that does whatever you like in response to that particular plugin being applied to your project. So the final lesson that we learned was to kind of ask ourselves, what would Gradle do? When we're trying to figure out what to do. And I think the best way to do this is just need to spend time immersing yourself in the Gradle way. And I think this is where an awful lot of our mistakes came from. We came, we were under time pressure. We wanted to have Gradle support in Spring Boot, but we didn't have a whole lot of Gradle experience. So we just kind of heads down, let's just write this, let's just get it out. And I'm glad we did. Whilst the original version of the plugin had plenty of warts, Spring Boot's Gradle versus Maven usage is roughly 60-40, Maven 60, Gradle 40. So Gradle users are a very big part of the Spring Boot community. And I think if we'd waited, then we may have left them behind, which would have been a shame. But on the other hand, if we had had the luxury of time, immersing yourself in the Gradle way and really looking, for example, at Gradle source code. So one kind of a penny dropped with me, and it seems obvious now. When I was thinking about Boot's jar task, and what we're trying to do is basically build a jar file with a bunch of jars embedded inside it, all of a sudden it occurred to me, that's a bit like a war file. Why don't I go and look at the source for Gradle's war plugin and war task and see how they've done it? And then I realized, oh, that's how they've done it. Oh, okay, so that repackaging stuff we were doing, that was nonsense. If I write a task, so Gradle's war task is a jar subclass that kind of adds a bunch of stuff by default to the jar. That's basically what boot jar does now. It's a subclass of Gradle's jar task that is in a lot of ways quite similar to the war plugin. It has an input which is basically, this is the main source set's runtime class path, where the plugin can set that. And it also means that we've got all of the power of Gradle's standard jar stuff. So the standard copy task, if you want to add extra stuff to your fat jar, to your boot jar, you can use all of the stuff that Gradle's standard copying support offers you for copying resources into the jar file and renaming them and transforming them and processing them and all sorts of things. That's all available because we're now built on the power of the things that Gradle offers in its jar task and in that the type hierarchy that we saw earlier. Another thing that you can do is look at source of popular third-party plugins. I learned a lot looking at the source of Gradle Shadow plugin. Hopefully you may be able to learn some things looking at Spring Boot's plugin. Source links coming up at the end of the presentation. And the last thing I would say is just if you're coming from a Maven background in particular, try and take off your Maven training wheels and forget Maven keeps you on this very kind of rigid, somewhat safe path. It constrains you an awful lot. And we brought that mindset to Gradle and thought, well, this is the way we did it in Maven. Let's just translate that kind of like for like, transport it into the Gradle world, rather than thinking, hang on a minute, we don't have those constraints anymore. What would be a much better way to do it? If we weren't constrained, what could we do that would be better? What things does Gradle offer us that we can take advantage of here? What capabilities could we get, for example, by extending Gradle's jar task rather than rolling our own custom task? And I think that is a really big improvement in Spring Boot 2's plugin, because we've now got these custom subclasses of Gradle's existing tasks. So all of the capabilities Gradle capabilities that people are used to having are all still there in our custom task. We're not kind of cutting people off from them by trying to roll a completely standalone task. All right, thank you very much. I hope that's been useful. I hope you've learned from our mistakes. The links here so the top link is so these are both GitHub links. I just chopped the start of the URL off just to make it fit on the slide. So these are github.com links. So the 154 link here is the old plugin, which is awful. I can say that because I wrote a lot of it, so I'm not offending anyone, hopefully. The 2.0 plugin is the new, almost completely rewritten plugin. So you can maybe look in there and compare and contrast and getting some examples of how definitely not to do things, and hopefully some examples of how to do things a little bit better. Thank you very much.